let's still get going because it's 7 after. Anybody try anything over the last week?
I've made a start, but I haven't got very far so far. Perhaps I could show you what I've done.
Sure.
Well, or what I haven't done. Yeah, so basically I wanted to like try and run it on like Google Colab as opposed to on Kaggle itself, just to so as I wouldn't run out of GPU time and things. But obviously the size of the data is a bit large to bring it into Colab. It's what, 50 gig, which would have taken up all of my space. So like what I thought I would do is I saw that there's a few notebooks about like this one here, the spectrogram generation, which, yeah, like it takes the data and sticks it through Librosa to generate output files, and like other people have done it where they take it through Librosa and generate images. And so like with this, there's like a few, there's a few like data sets that have been generated from that kernel, which are much, much smaller. So you can see like this one here is like 2 gig, or the one I have is 5 gig in size. But basically what it is, so he's converted all of the data into like NumPy spectrogram things. So like over here, this one here, so now I have his data that he's generated. So he's got like the training and the test data, and it's just like loads and loads of NumPy files, which I can then bring back. I can like open up one of these files and stick it back through Librosa, through this spec show thing, which generates me this spectrogram. But I've actually no idea what I do now with this. Like, so like here, it's like sort of saying that this data has 64 nmels and it's generating me this spectrogram. But I wasn't sure how I actually take that and actually do anything with it. Because like the other people have sort of done CNN models in the competition. They've saved the spectrograms as BMP files or PNG files, as opposed to having like NumPy arrays. So I wasn't sure exactly what I should do now. Do I need to take all my NumPy arrays and like convert them into images instead, or is it? I don't actually know. Yeah, so like here it says it's got for one of these NumPy arrays, it's like 64 by 3751. I take it the 64 corresponds with the nmels, but I wasn't sure how this relates to like the training data. Like how would it relate to like the tmin and the tmax? So
yeah, actually, Steve, I think in fact what you've done is a great start. In fact, I went through and used a notebook. I believe it is the same notebook that you had originally used, Ryan, and submitted, and went through it, and I can go through it kind of mostly step by step. So it kind of addresses many of the questions, not all of them, because I still have some open questions myself on some details of what that notebook is doing, but he does it online, but you can see where you could just store what he's done, and what he has done is pretty much kind of the first step he does is very similar to what you have done, and then he does it for lack of a better word, online, in the sense that he stores it in Kaggle temporarily itself, because it can store up to 20 gig, I think, that it can use dynamically. Yeah. But you can do what you're doing, and and then figure out, as we go through that notebook, you will kind of grasp what next steps could be with that, with what you've generated. And I can go through that after others have had a chance to kind of present what they have been able to do. I did that last week and took that notebook as well as a variant of that notebook, and I'll go through that cell by cell.
I think I missed 1 week, I think, which was maybe when you went through like all the basics of like what males are and the male spectrograms and stuff. So I think I'm missing some basic knowledge. I think I need to go through those YouTube videos you posted about sound processing to understand a bit more.
Yes, that really helps. Yeah.
Yep.
Yeah, I just want to mention that those video series is just great. I watched it instead of, you know, it feels like recreational stuff.
Yeah, I started watching.
What? I'm sorry, Arto?
Yeah, I'm saying that this video series you linked from that, you know, like audio processing series, it just watches great smoothly. So I'm saying it's really enjoyable.
Yep, thanks. Yeah, no, I felt the guy did a superb job of explaining things and kind of switches between theory and examples, and so it really quickly ramps you up on what you need to know.
I just started listening it, but he mentioned that besides this series, which goes into audio processing, he has deep learning for audio. Have you listened to that? I think it's a different series.
Yeah, no, I haven't listened to that, Yuri. I wanted to kind of get into applying. I haven't had a chance. No.
Okay.
So anybody else try anything on this competition and want to share?
Yeah, I just started.
Go ahead.
With this notebook. Yeah, I basically did this fast audio stuff, like not from the notebook you shared, but based on some document example from documentation. But I don't think it matters much. And yeah, also I tried, as they recommend, adding some mix-up, and it improved substantially the result. And I tried some hyperparameters from that exploration on weights and biases we checked out last week. And yeah, so it was, I just tested it. So it was like moved from around score of around 60, I guess, what they had with like those default notebooks had with which you showed before, and it moved like to around 70. But that I wasn't like fine-tuning anything. I just took ResNet and added this, like changed this preprocessing a bit and added mix-up. So that definitely helps. And I checked a couple of papers, and they all mentioned that mix-up augmentation on spectrograms are very useful.
Mm-hmm.
Yeah, and another thing I'm looking at is this. You can basically generate like 3 channels, applying this decomposition to the spectrogram, and you can get like harmonic and percussive components. So in this way, you can get a like 3-channel input instead of 1 channel. And so I saw this in some report linked to this benchmark, one of the benchmark data sets. There is a report which like second place on that benchmark, and they used this decomposition for 3 channels, but I just tried it on a single example and it took like almost 8 seconds for a single example. So maybe that's why it's not so popular.
But you know, one of the things you could do with that, I haven't gotten to that part of the thing, and maybe Steve or I might even go back and pull him to, if he has done fancier things than just submitting on TPUs. Did you use TPUs with that and see whether it reduced the time any significantly?
Well, that it's done by Librosa, so it's basically, I think, CPU based, right? And I found that there is no official there is no implementation in PyTorch, but there is a library Torch Audio Contrib or something like that, and they had implementation for this, but I think they merged all into Torch Audio, and this feature wasn't at least yet it's not in Torch Audio, and it's labeled beta in their old repo. So I'm not sure if we can use it. But on the other hand, if we go this way as Steve did by pre-generating spectrograms, not doing it on the fly, but pre-generating spectrograms, it can be done once, and then it could be a shared data set with these 3 channels. But yeah, I'm still not sure if that's really useful, first, and second, how do you tune hyperparameters of that transform? You can change some hyperparameters there, and it makes it spectrogram, at least spectrogram visualizations are really distinctive with that. So it can be found in Librosa library. It's called harmonic percussive source separation. And
yeah, if you could post a link or stuff in the chat, that'd be great.
Yeah, sure. I will post a link. Just so, and yeah, so I was wondering if maybe before moving to next notebook, should I talk about this weights and biases thing I mentioned?
Go ahead, please. That you can mention it now. That's a good point.
Yeah, all right. So
go ahead.
So I just there were some questions about weights and biases during our previous sessions, and I happen to know a guy who works for weights and biases now. So I asked him if we how can we have this Steam account for our study group, and he told me that it's really it should be really simple. We can apply for academic account, and it should be free for teams. And yeah, so with that we could log all the experiments we run on weights and biases, and yeah, so we would be able to track the results and maybe formulate some reports and like compare runs, like basically we can speed up our hyperparameter search. Say, for example, like multiple people could run experiments with similar models but slightly different hyperparameters, and then we could find the best, like quicker. And another thing is that like you can use this sweep functionality for hyperparameter search, stuff like that. So I just was thinking that this functionality weights and biases provides could be really useful for our group. And if you guys are interested, so he also offered like there is a weights and biases, another guy who works for weights and biases and who provides some Kaggle content for them, and we could arrange some like demonstration or presentation for our group. So
yeah, I think that'd be really cool. Yeah, I've only started using weights and biases like in the last couple of weeks. Previously, I used to use like Jovian for sort of storing notebooks and sort of comparing results and things. But yeah, like in the last week or so, I've started using weights and biases, and it is really good. It's a lot better. It's like, and like the fact that you can sort of track your experiments as they're running, and as you say, the sweep functionality looks really good. So if it'd be possible, yeah, to have that for this group, that'd be excellent.
Yeah, thanks for the initiative, Otto. I think it'd be great if you could, figure out what we need to do. I can, or even you can take the steps to set up the academic account, and also whenever the person is available, if he can come in, we can make the time for him to present to us. So both of those things would be really useful and helpful. And I think I'm seeing increasingly usage of weights and biases in publishing of results. So I think that would be great.
Yeah, their like functionality for reports is really handy. For example, when we like collaborating on this reproducibility challenge, we had like big fraction of the report just for almost no effort. So that's really useful. And yeah, so I will check what should we do to start this Steam account and add members and stuff like that. And I will message you with the details. Also, this person from Weights and Biases who does Kaggle stuff, he joined. I saw he joined our Slack channel, and also Joseph expressed some interest towards doing Weights and Biases workshop on TWIML. So maybe, so I'm not sure how we will proceed with that, but I guess that some short presentation for our group would be great, right? So I should.
Yes, that would be great. Yeah, especially in the context, of course, broader for TWIML, that would be awesome too. But in this case, specifically, there may be some things related to Kaggle that we may or may not need, and or maybe they have done something with respect to usage with Kaggle. If not, maybe we may even request and or interact in that perspective. So yeah, if he can talk to the group and present, that would be great.
Right, cool. So I will just see if he can do it next meeting, and I will post
Sounds good.
you on that. Cool.
Yeah, sounds good. We can make the time for him to do that. That'd be great. Thanks, Sato. Okay, anyone else? Want to?
Hello. Can you
Shiva,
hear me?
you want to say something?
Yeah. Can you hear me?
Yes.
Okay. I'm just starting the competition. I'm just running the fast audio starter kit notebook. I was just noting some issues, and after that, I was just going to the fast audio library. I was just doing it. I think that's all.
So you faded out towards the end. What were you saying about the fast audio library?
I was just running the fast audio starter kit notebook which you have shared on the group, and
Right.
I was just at some like blocks while creating data blocks. There was some error or something, so I was just checking the fast audio library. I was just checking. I'm just
I see.
yeah, that's all.
Okay, and you can feel free to post if you continue to have problems. Post what specific error messages it throws up and stuff like that. If you don't have success in debugging, and people may be able to help. So post it on the Slack channel if you continue to face issues.
Okay. Sure.
So that reminds me, I was checking the transforms pipeline in fast audio, and I think by default, yeah, let me open it just to verify that I'm not mistaken. Just a second. So I think that by default, fast audio resamples to 16,000 kilohertz, right? And it might be not such a good idea for this competition as the there is this statistics for highest frequency in annotated sounds, and I just checked, it's over 13,000, and I believe it's better to have your sampling rate higher, like twice higher than the frequency, the highest frequency you care about. Is that right? So I'm just
yes, that's the Nyquist criterion of the or stated exactly the reverse way of what in order to assess frequency F, you need to sample at least at 2F if you want to analyze F thoroughly. So your sample rate needs to be twice what the max frequency, or you can state it the other way, saying the best you can get, the best analysis you can do would be at half of the sampling rate. So you would be limited if you're doing the sampling at 16K to analyzing up to 8K.
Yeah, so I'm just wondering if this works the same way for continuous, like this Nyquist frequency idea, right? It's related to the like digitalizing sampling the continuous signal, but I suppose it holds if we just resample digital signal, right?
Yes, I believe so.
Okay.
Okay, anybody else? okay. If not, kind of, again, as I said, this is the notebook that Steve used, and it also gives a good next step from the notebooks that I shared previously, in the sense that it begins to do some of the things that the prior notebooks didn't, and in a different way. So it results, and I think Steve already shared the results, but I can also confirm that it gives you results in about the 70s. Let me share my screen. Can you folks see my screen?
Yep.
Okay. So I think this is the one, right, Steve, that you had used, all-in-one RFCX baselines for beginners?
Yeah, that's the one I just used to check that we could submit okay. So, yep. Right.
Yeah. And you can see that when I used this notebook and submitted, I got a score of, somewhere 0.75 on the private, 0.73 on the public. So this is better than the scores I had previously. But this still, after we go into the notebook, you'll see that it's still, there's still many more things you can do to get, obviously, we know that because some of the best scores are in the 0.98 domain. But as we go through, I would encourage people to think of what else we could be doing, and you can kind of see what else we could be doing. As we go through the notebook, you'll find instances of where things could be changed, modified, improved, and so on. So, let's go through it cell by cell and try to understand what he is doing. Some of the questions with respect to what Arto brought up and what even Steve was praising are answered, I think, by going through this notebook, or at least as I began to understand what the notebook was doing. So here, the Fft size, which he specifies as 2K samples, 2048 samples, and the hop is how much you slide the window by, or how much you hop from slice to slice, and that's 512. So you can see that if, for example, your size is 2048 and you hop 512, then you just hop by about a quarter, and 3/4 of it will still have an overlap. If there are 2048 samples and you hop by 512. By the way, the sampling rate, native sampling rate of these audio samples is 48,000. How do I know that? I know that because actually this is incorrect where I've stated the Librosa default. The Librosa default, I think, is 22050. I should modify this comment, and I will before I post a link to this notebook. But what you can do is when you do the Librosa load, and if you say SR is none, the none option, and you can go to the Librosa documentation, which is how I found this, would then return you the SR of the native sampling rate of this waveform. Okay. Of course, you can specify a number here, in which case it will resample what it is loading at this rate. But if you give SR equals none, then it returns the waveform, but it then returns the waveform at the and uses the native sampling rate of the waveform. That is, whatever the sampling rate was that was used to generate the waveform, that's what Librosa uses. And I found that by going through the documentation. So that's a thing to keep in mind. And the other thing is the native sampling rate is 48,000, right, of the waveform files that we have provided in this competition. Now, here you'll also see that he uses the fmin, fmax, and we'll see in a minute what he does, what he uses this for. So what he uses this for is, he says, okay, I am going to kind of I know that in this sound file, most of the information is in the lower frequencies. So, the other way, there's noise in a lot of the low frequencies, and therefore I'm going to chop them off and only focus on a frequency range above that. So he uses a min and a max, and in order, and then with some margin of, so 0.9 of Fmin and 1.1 times of Fmax. So what it means is he takes frequencies which are up to 0.9 of the 24,000 on the upside, and then, you know, not 0, but 10% above that. And so that's kind of the frequency processing in order to focus on the desired frequency range is what he's doing here. And he just reads, by the way, for whatever reason, he processes the CSV file and converts it to a list. That's what the data is. So the data is stored as lists of lists, which is the reason then you can say data I. So this is just the whatever the ith entry of the list, and then the fourth column. And the columns are these guys. So that's why you can see that the fourth and the sixth columns will give you the Fmin and the Fmax, and he kind of processes them here and puts in a margin to narrow down the frequency band of focus or concern that we have. And remember, this is still in the native frequency domain. That is to say, it's not MEL frequencies, it's just native frequencies. And the sampling rate is 48,000, which is the reason that, in a sense, the max is the 24,000, half of the 48,000. The other thing to focus on, because I think this is interesting and important, and as we go to more advanced notebook, I'm sure this will get more involved and complicated, is, so what he does is he takes a 10-second duration of sample. That's what he defines as the length, and we'll see how that matters as we go down the rest of the notebook. Because the sampling rate is 48,000 samples per second, so when you multiply by, say, 10 seconds, then this is 188,000 samples total of length, but it's a length duration of 10 seconds. Any questions on just this part? Okay, if not, moving along. So now you generate the spectrogram from the FLAC files, and you just do the, you generate the wave file and the SR, and as I mentioned before, none means do it at the native sampling rate, which is 48,000. And here's where it gets interesting, and this is something that obviously was not done in the previous notebooks that I shared. So for each record, the additional information we are provided, as we saw here, for each recording ID, it tells you the species that are found. Of course, the song type is just 2 types, but for the species, it gives you the Fmin, Fmax, which we have used here to narrow down the frequencies of interest. It also gives us the Tmin and the Tmax, right? Where is that used? So you can see here, he uses the Tmin and the Tmax to get to the samples where Tmin and Tmax are. By that, what I mean is, because the sampling rate is 48,000 samples per second or hertz, then the Tmin is that times SR, and the Tmax is the Tmax value times the SR. And then he finds the center of that window. Obviously, that's clear by just doing, Tmax and Tmin plus 2 to find the center point or in time. And then this is where it gets, again, the length becomes relevant, because what we want is a 10-second sample starting with the center as the, not starting, actually with the center as the midpoint between Tmin and Tmax. And that's what he's doing here. And obviously you could have a situation where the Tmin is close enough, or the center, I should say, is close enough to the left edge that your center minus the half of the length will put you on the, below 0, in which case he snaps it to 0. And the same thing on the other side, if your center is too close to the right edge. And then you just create that slice, 10-second slice, with the center being the midpoint of the Tmin to Tmax. Again, is that clear? So
sorry,
it takes a 10-second.
Each of the samples is 60 seconds, is it? In total length, and he's taking 10-second samples around the center of where the center of where the animal is meant to be.
Yes.
So
where the species ID is for that recording for that species.
Yeah, but
Yeah.
the total length of the WAV file, of the original WAV file, is 60 seconds. Yeah. So he's taken a sixth
That's
of it.
right.
Is it? Okay. Yeah.
Yes. But 1/6 around where the sample is.
Yep.
Corresponding to the, because the Tmin and Tmax are provided for that particular sound species sample, right?
Yep.
So yeah, okay. And he generates, and the next steps are, he just generates the MEL spectrogram for that 10-second sample. Okay. Then now here there are a couple of details, because you can see that he just passes the slice into the MEL spec, and you can create this. A detail as to this power. I mean, obviously we saw this already, but the NFFT is equal to FFT, which means this is 2048. The hop length is the hop. Now, this is where you'll need to understand a little bit of the sound processing. So it takes a 10-second sample. Now, remember that a 10-second sample is 48,000 times 10. So it's 480,000 samples. Those samples are digitized, converted to Fourier transforms at 2048, at a time when you do STFT, short-term Fourier transform, you take that and you hop by 512 each time and convert that. That's what it does when it, that's why it needs this FFT, which is 2048, and then the hop length. You provide the SR, and you provide the Fmin and the Fmax. The thing that I didn't quite understand is initially, still my understanding, I would say partial, is the power is 1.5. So what does the power do? So if you go back to look at the Librosa documentation, what the Librosa documentation says is, if you have a power equals 1, that's the energy of the sound wave, and if you have a power of 2, then it is a power of the sound wave. Now he's taking in between 1 and 2, which is 1.5, and later on in the question and answers, if you see for this particular, if you go back to his original notebook and look at the Q&A, somebody asked him, why do you use this? And his simple answer is, oh, the figures just look better. The other thing you will notice as we go through the rest of the notebook is he does not convert, again, some sound basics that you'll understand. If you don't, it will sound like gibberish right now, but if you go to the videos I'd link to, then you'll find that what the spectrogram does is plot, and I'm talking just spectrogram, not MEL spectrogram, is plot the frequency versus time, and what it actually plots is the amplitude. On the colors show you the intensity of the amplitude with frequency on the y-axis and time on the x-axis. Now, if you could do the amplitude on a log scale and then plot that as colors. If you do that, then you would be using this guy, the amplitude to dB, because converting it to dB is essentially using log on the amplitude. So it's just log amplitude. So if you use power is 1 and you convert it to, then you convert it, what you use for conversion is amplitude to dB. If you use power is 2, then what you use is librosa.power to decibel. Now, since he does 1.5, you can do neither, but what I found in this notebook, which is again a potential source of some experimentation we can do and see whether it really matters, is he doesn't convert the amplitudes. Since he gets something between the amplitude and power, he just uses their values as is rather than converting it to dB or taking a log scale or anything of that kind. Okay, now these are the values that are plotted in color intensity. When we change from frequency to mel frequency, what we are changing is the y-axis, not the values that are plotted. Keep that in mind. The values that are plotted is either amplitude or power. That's the color of the waveform. Color of the spectrogram or mel spectrogram. The y-axis is the frequency or mel frequency. Okay, and in this case, as I said, again, a level of detail because I was confused by, I didn't see any of the other notebooks use power, but he seems to use this. We could potentially use just power as 1 and see whether it makes a difference, or use power as 2 and then convert the result that you get, the mel spec, to a dB and plot those spectrograms as well. Because that's what, if you go back and look at the Fast Audio or the PyTorch audio, Torch Audio notebooks, that's what you'll see them doing. They'll convert the amplitude to decibels and then plot it. Then he just uses the resize to resize the image. This is something else, Steve, to think about as you generate the spectrograms and store them away, is, whether any size in particular is helpful or a bigger size is helpful or what. Just something to keep in mind. And then he goes through this. Now, this is where, again, an open question for people, as I made a note to myself. I don't have the answer right now, but I'll just share the open questions as I go along. Is, he begins to normalize the mel spec and stuff. And I'm just wondering whether if I converted the values to decibels, would it still be okay to go ahead and do this normalization and stuff? Because I don't see other notebooks which were just using the decibel values of the amplitude do the normalization like he does here. But be that as it may, so that's an open question as we delve into the sound details. Let me know if any of you find and come upon or have reasons that you yourself think of a good answer for that question. But here what he then does is, obviously these are mel spec values, because the Librosa, this particular command generates the mel spectrogram itself. And if you again go through those notebooks, you'll understand that mel spectrogram is, as opposed to ordinary spectrogram, the y-axis gets converted from frequencies, normal frequencies in hertz, to mel frequencies. That's also in hertz, but the difference is it can go through the details in the video. I might screw up what I'm exactly saying, but it the MEL spectrograms or the MEL frequencies, the way to think about them is they adjust the frequency bands so that they include the sensitivity of our ear as a factor in how the frequency bands are generated, because our ear is not, our hearing is not as sensitive to the frequency bands at higher frequencies than it is at lower frequencies. And that adjustment is what converts the y-axis frequency from frequency to MEL frequency, and here that is automatically done by Librosa. So you get MEL frequency on the y-axis or MEL bands, which is band of frequencies, and then time on the x-axis, and then amplitude of power or whatever MEL spec or as your values on the chart. So then here he just normalizes it by subtracting the minimum, dividing by the maximum, converts this to 255 in order to save it. This is what Steve you were referring to of what you can see people saving this, rounds it, stores it as unsigned int 8 values, and then converts it to NP arrays. So this is the NP array that you saw Steve point to when I say this. I don't mean exactly these values because Steve went to a slightly different process, but bottom line is this is analogous to the NumPy arrays that Steve showed in his notebook. And he then, just saves the BMP files with the information. Now keep in mind that the information here is data I0 and then an underscore and a data I1 underscore and a string of center.bmp. So what this does, it stores the data I0 is basically the recording ID and data I1 is the species. So it says for this recording, for this species, for this center of the 10 seconds sample we took, here's the BMP file, right? And stores that and then says, anyway, he's just printing. And this is where I was saying, Steve, that he is storing it directly right now. At least you can create it instead of writing it to a disk outside or something where you can store it outside of Kaggle, if you will, and then, or even as a data set, and then I can upload it as part of, say, your input. But here he just stores it and reuses it in the notebook further on down. So this is the process for generating the 10-second sample from the 1217 records of the species sounds and generating the MEL spectrograms corresponding to each of them and storing them as BMP files. Any questions? Okay, so moving on, here all he does is some seeding and just creates, the number of birds. Obviously species is 24, 23, and then batch size of 16, some seeding stuff. Here creates the class of how to create the data set for the data, so we can use the data loaders and so on. Just creates here a one-hot array corresponding to that, corresponding to the label for each, and then obviously self.labels.append the label array, and you can see the label array just says creates an NPs or zeros, and then the label array of the label, and obviously the label is the split from the underscore, and then take the first value, which would be the and then convert it to an int, because you would get the number of the species that you're finding in that sound clip, convert it to an integer, make an array of zeros, use this int value to index in and make that a 1, which means basically you're creating a one-hot array. And then here he just points to the fact that, the problem with this approach is that, it works for 1217 record ID, which is all you have in the train train TP, but if you add train FP and stuff, then this becomes too big for in-memory storage, and you better in that case go to storing it separately and then using get item, because they all will not fit into memory. But right now he's able to fit it because he's just using the 1,200 samples that exist in TP. Okay, so he opens the image, pulls the MEL spec, because he has multiplied, when he stored it, he multiplied by 255, so divide by 255. And this is some of what Arto was referring to earlier, that because our, later on you'll see he uses ResNest, but ResNet, it doesn't matter. I mean, ResNet or ResNest or EfficientNet, all of them native use 3 channel images. So he just duplicates the single channel and stacks them to create a 3-channel image. This is where Arto's comment about, maybe the other channels could be used to provide harmonics or other relevant information, thereby improving your processing rather than just simply duplicating all 3 channels with the same information that you have from a MEL spectrogram. But so far, at least, this is the approach we have seen consistently all notebooks using, except of course for fast AI, where that's the advantage. You can just come in and say n channel or n underscore in equals 1, then automatically it knows to convert the model into a single channel input, whereas these guys don't have that capability, so you just end up duplicating the input and creating a 3-channel input. So that's kind of what he does here, is creates the specs item, which is each of the spectrograms, and then the labels, which is the one hot. Any questions? Okay, so even though he shows, and I could make sense of what this picture, but basically I assume most of you folks know stratified k-fold. Even if he calls it out and splits the data using stratified k-fold, he in this notebook just trains on 1 fold. And that's one of the enhancements that I'll also share with you. There's another notebook which just enhances this notebook to just apply stratified k-fold. And it is the right thing to do to use the stratified k-fold, because if you were to actually run this notebook, train it, and then run it on the test data, you're likely to get more of a variation than if you had done it on a stratified k-fold, because stratified k-fold stratifies the validation data and ensures that the distribution of the 24 sample or species ID is proportionate in the validation set as it is in the test set. Okay, so that's what stratified k-fold does compared to just regular old CV. Okay, so file list and label list, here he's just creating the files and the labels. So he does a 5-fold split, creates the training and validation indices by splitting them. And so again, as I said, in this particular notebook, he just uses 1 fold. So because he just uses a single fold and splits the data, assuming that, and it's not assuming because it is SKF, the stratified k-fold in SK does split to 20% in the validation set. So I should reword this, but not assuming, but it is a 20% validation split. So what that means, because he's just using a single fold, is the fact that he loses training on that 20% of the data, which is only sitting in the validation and not included ever in training. Obviously, if you did all 5 folds, then that would not be the case, which we'll see in the next notebook. So, and I say that here that you can train on 5 different models, and then ensemble them, and that would also make the results more predictable. So here you just say if the fold is 0, take the indices from the training and the validation split that you've done here. Again, any questions?
Yeah, I have like a very basic question, which I don't know why I don't know answer for, but do you know what is generally better to train a model on with k-fold and then use ensemble, or just to find hyperparameters and then retrain model on the whole data set? Is there any like rule of thumb for choosing between those, or it's always better just to do as much ensembling as you could?
Excellent question, Atto, because it's funny you asked that, because in a personal chat with somebody else just earlier this week, he didn't exactly ask this question, but that's where we were headed to, saying, is it better to do a grid search of some kind, determine the hyperparameters? But my only question on determining the hyperparameters is that hyperparameters of a grid search would give you the hyperparameters for a particular model, right? Because the hyperparameters can't be over a set of models. It will give you the best for one model. So wouldn't, in that case, also you would need to do, or correct me if I'm wrong, but even in that case, wouldn't you have to do a grid search, for example, for each of the 5 models that you come up with here, rather than grid searching, because you cannot grid search a set of parameters independent of the model, right? You would still find a set of parameters, hyperparameters, corresponding to a model. Or am I missing something?
Yeah, so what I'm thinking about is like you do the hyperparameter search with k-fold, right? So you find a set of hyperparameters which is best on average on your k-fold validation. And then you take those hyperparameters and just train model on whole data set. So
and all of the data, that is, at that point, you do not do k-fold anymore. You just use all of the data, is what you're saying.
Yeah. So you don't know, like you cannot be sure what your validation score is because you don't have any validation data. But
right, and also my question is, what would be the model that you use in that case? Which model would you use in that case? Hyperparameters, whatever you come up with, what would be the model that you're using in that case?
It's the same model, though, isn't it? It's just you would train it on all the data as opposed to only 4 out of the 5 folds. I think a lot of people, though, the reason that they only train on one fold is just like for time constraints. Because like obviously if you've got like 5 folds to train the 5 models and create like an ensemble from the 5, takes an awful lot of training. Yeah, so like people tend to sort of create their model and fine tune their hyperparameters just from one fold, and then they go, okay, well, my model hasn't been trained on 20% of the data here, so now I'll just like train it for a couple of epochs more, so as I have trained on everything. But I think in general it's better to train on all of the folds and like then ensemble, but it's just takes a lot longer, obviously.
Also, I recall I saw a paper which or maybe blog post, I don't remember exactly, and the heading was like don't throw away your like bad runs from grid search or something like that, and the author was claiming that like when you do a hyperparameter search, you can still utilize your like models which turned out not to be the best ones, but the ensemble of those models turns out to be better than the best model you found by hyperparameter search. But I'm not sure, like, I think that's really depends on the data regime you are in. So here we have like around 1,100, like about 1,200 examples, right? And so that data set is kind of small, and so I think those choices are really important in cases like this.
Yeah, I agree. This is an open question. So yeah, if you could find those blog posts and post it, I'm fascinated by this question as well. Since it just came up in another conversation I was having. So it's an excellent question. I don't know other than what we are saying right now, which I think Steve stated the issue of computation, which I also had flagged in that other conversation, that's the trade-off. But I don't know whether there is a guideline for how to approach it other than empirically trying. But if there is something which says, here are the principles by which you should approach it, or here are the guidelines, that'd be great. I mean, other than the obvious one of, hey, you do one fold because of what Steve stated. But, you know, your blog post or link would be excellent to read. Okay, it's a good discussion. Then he installs the REST nest model. I'm going to defer the other than to, do I have the PDF open? The REST nest model, let me see, can you folks see the paper that I have open?
Yep.
Okay, so bottom line, again, this is one of the papers at the end of the competition that we should go back to and read and become familiar with the details, but rather than spend too much time right now, because it's just a component of our overall approach, unless folks want to dive into it, which will take quite a bit of reading and comparison and stuff. The key point I would say is it seems that REST nest is even better in terms of the latency and better in terms of the accuracy performance than efficient net, which the efficient nets themselves were deemed better than just a basic REST net. So that's the reason I think that in this case he's jumped to using REST nest. As for the details of what this does differently, I think we should definitely go back and look at the paper in detail, but let's defer that unless anybody has any other objections to the end of our discussions on the competition. Because I've seen so far people use REST nest as well as efficient net in different notebooks. So the bottom line, why REST nest is being used, I think, is it's supposedly more accurate and more and better latency than efficient net.
I believe the efficient net v2 was released also, and I think this is comparison with the v1 version, right? And
yes, I haven't checked that, but which version of efficient net this compares against?
Did this just come out in December 2020, or is that when the paper was put up?
That's when the paper was put up, but
yeah, because I get this Kaggle competition was what, 5 months ago, was it?
Yeah, 4 months ago or something. Yeah, ended 3-4 months back, 2 months back, something like that.
No, 2 months ago.
Oh, 2 months, right?
Yeah.
Yeah.
The code is also available. I'll post the links if people are interested in digging into it. I just deferred getting into the details of it until we get much more towards the end of the competition, and we can drill down on it if it still is relevant and gets us good scores, or it's a good thing to learn ongoing basis. And
this is
the
still
interesting thing is,
a model.
Sorry?
Model is trained on just ImageNet, right? The one.
That's correct.
The one he
Yes.
uses. Okay.
Yes. Yeah, the REST nest is trained only on ImageNet. And apparently he claims, obviously, in the paper that is being used as a backbone for semantic segmentation, identification. And if you go to the GitHub link, it kind of points to in each of those mint marks, what place using this network as a backbone, what positions those algorithms achieve for those tasks. And it's somewhere in the top 10 for sure, for most of them. Some of them top 3. The other thing which I learned, and I didn't know this, but maybe it's just me, maybe some of you who know this and have done a lot more of this can educate us even more, is, apparently for REST Nest and for RESTnet, but not for AlexNet and not for a couple of other ones, the model has a final layer and it's an FC. So you could just replace the final layer by doing this. If you have imported a model in through PyTorch, blah, blah, blah. So that's, again, something that I found interesting, that, obviously, if you, in FastAI, you kind of, attach a head and freeze, train just the head. This is kind of the equivalent in PyTorch. You just say model, but not all models have the FC. So the reason I was like, how come this just works? So what does he know? And then I'll post a couple of the links which point to this, but the REST Nest and even RESTnet, I believe, have the model with the FC as the final layer, and therefore you can replace it. Obviously, there's a fully connected last layer, and that would be for whatever it's trained, the 1,000 ImageNet values, and here you just kind of go and replace it and get, and then I would assume in this case it's also 2048, because that's what you start with, and you end up with the number of birds as the output. Anybody else very familiar with it already and can speak to more of it? And I'll post a couple of links which kind of at least showed me why or how this works, and what you would do in those other instances where it's not just, because bottom line, what you need to be aware of in order to do this is this model of RESTnet and how you would replace the head to customize it to get your eventual classification output, whatever your number turns out to be. And that's what those links explain for the various models. In this case, it's simple because you just replace the fully connected layer at the end with this sequence of layers.
So he just downloads the big bone from the official repo, or what is where he took the architecture?
I believe, let's see.
Or is it in like Torch Hub?
It's from Torch. Yeah, it's the Torch.
Okay.
Torch Hub. And I believe that Torch Hub stuff is what lets you do this. Because I found the explanation for doing this in Torch documentation.
I've done stuff like that with, like the models out of TIMM, TIMM. And yeah, so like each of the different ones, as you say here, like the ResNest ones or the ResNext ones, it's .fc, but like EfficientNet, it's like classifier.fc, and one of the others is something else. But yeah, there's like sort of just different variations.
Exactly. Right. Yeah. And in some, it's not FC, but it's something else. So what that is, and at least I hadn't done it in a while, or I'd forgotten about it, but that was an open question of mine in this note, and that's what I found out, Steve, exactly what you're saying, that you just need to know based on the touch-up details of what the layer is that you want to replace as the head. And once you know that, by going to the touch-up and the documentation, then it's just a simple matter of replacing it with what you want. And it's different for different networks. It is FC for ResNest and for all ResNet variations, I think, and also for ResNet without the S. Okay, moving along. He just uses stochastic gradient descent, and then he uses the step LR. Again, it's been a while, or I have forgotten what step LR does. So basically, it reduces the learning rate after every so many steps by gamma. So what that means is after every 7 epochs, the learning rate is reduced to 0.4 times whatever you started with. And then at the end of all of those epochs, it reloads the starting learning rate. Again, just a detail that I didn't recall, so I wanted to figure out. This is something that if anybody would like to even do a presentation on, I know we discussed this in prior competitions, but this is one of these, like, precision and recall and stuff that I constantly get confused and have to go back to the documentation and wade through it one more time to get it re-hammered into my head. Maybe my skull is just thick, but if any of you are more familiar with it and would like to talk to the weighting, especially the positive weighting and how that works and why it's something to do and stuff, and what the right way to do it. I'm not convinced that he's doing the right thing, because here he's just loading it with all ones and then using it as is. It doesn't make sense. If you read the documentation, it says that you would, let me see where, but I again do not want to spend, in the interest of time, I want to go through the whole notebook and not spend too much time on it, but I'd request anybody who understands this after going through it, and obviously I'll spend time on it over the next week too, but if you folks, I'd really appreciate it if you can look at it, and if you have a clear explanation with some examples that you can say. Rekil had done this in one of our previous discussions, but unfortunately I've forgotten and I'm again lost, or at least lost in a sense I don't get it, which means I'll need to work through it in order to get back. So this is the positive weight, a weight of positive examples. And if you look at the equation here, he talks about it being used as a balance between the recall and the precision. So if in the notebook, he just keeps it as 1, which would mean that it's neither greater than 1 nor less than 1, it's equal to 1, in which case he's kind of balancing the recall and precision and not influencing them in any way. But then I don't understand what the point of it is, because, or maybe the point is he just wants to leave it as default value, in which case then he could have left it as a default value without giving the positive weight. Because here the thing says that if your data is 100 positive and 300 negative, you would actually want to put the positive weight for the class to be 3x.
But
and
isn't
that, I think,
he
is
multiplying it by number of birds there before using it? So it just reweights with numbers of labels in dataset, like with number of corresponding labels. Could you go back to the
yes,
notebook?
You're right, but you're right. If we go back to the thing, he just multiplies by number of birds, but
so this
that just multiplies everything by, and numbers, if you see here, is just simply 24.
Is it 24? Yeah. So he probably did it by mistake, because in this way it makes no sense. So I would expect numbers to be counts of respective labels. In that case, it would balance the data set, and it would result in it would shift this precision recall trade-off towards. I too don't remember the details of it, but
right. So
I think it's what meant to do here.
Yeah, that's my understanding too. That right. That so if I understand you correctly, Arto, you're saying that this would, let's say we have very small number of positive samples for a particular class, then this would balance it by boosting up that number as a way of speaking. Is that correct way to think about it?
Yeah, that was I meant. So it's like supposed to be like inverse of so less presented classes should be upweighted, and it effectively would be equivalent to oversampling, right? So we could do the same, achieve the same by oversampling the less present classes.
Correct, exactly. That's my understanding, but this doesn't at all achieve that goal, right?
Yeah, what they're doing here, I'm not sure what he's trying to do, but does this not match exactly with what they have in the example on the PyTorch page you were just showing? If you look at what they do, they look to be just putting in like an array of ones as well. You see the example there? So it's got the pause weight torch ones 64. Is that not what they're doing exactly there?
Yeah, but they do it just for demonstration purposes. How do you feed and what shape should it be? And here in Torch example, it just does no reweighting. And what he does, he just multiplies each loss by 24.
But is he not? You see, like there, they've got like pause weight equals torch one's array of 64. He just put in. Is he not just multiplying by 64? So he just ends up like an array of 24 pause weights, which is just the same as doing it like the way they've done it. You end up with the same thing, is it not? But
yeah, but yes, I agree that he's doing exactly what this example shows, but I don't understand what that would achieve in balancing, because ultimately our goal is to do what I think Arto and I are saying, which is to oversample the less frequent labels and balance them out in the data set. And if that's your goal, just multiplying everything by 1 doesn't get you to that goal, which is the confusion I have. And I think Arto is questioning as well.
yeah, like I'd agree, but yeah, it looks like he's doing sort of exactly what the example does, which I don't know. Is it basically sort of saying that just treat all classes exactly the same and don't weight any of them? But yeah, I don't see the point in what he's doing.
Yeah, but in which case then, right, in which case then why care, right? Because then just don't give positive weight, just say none.
Yeah.
That would just, if you're multiplying by 24 to everything, it doesn't change anything. So other than making the loss numbers different, it doesn't change anything. So might as well ignore it. So anyway, that I don't want to get bogged down, but it is a open question. So if somebody can dive in and present short, I'll post the link, this link as well, but an open question with respect to this notebook, at least for me, I didn't get what, and he himself in the Q&A for his reference notebook says, I'm not really sure what I'm doing, but I'm just following documentation.
Yeah, it looks like he's just copied the example and not really thought about it.
Yeah. But it doesn't seem to accomplish what, and Rekil for sure understands this stuff more, so I might ping him offline to get his take on it too. I used to get it, but I've forgotten. And I'll have to go back and look at it. Okay, moving on. So that's an open question. If anyone of you can kind of dive into it and give us a short, oh, here's what we're trying to achieve, and here's how to go about doing it, and here's what is wrong, blah, blah, blah. But I guess it doesn't really change anything, because overall, I mean, you can see his results are still pretty good and better than before, better than other notebooks. So moving along, here he's just doing the training loop. He's training for 32 epochs, training loss, and how much of the training is, how much of the thing values that you're doing is correct. One more thing I wanted to mention before we get into this detail. See, each recording ID sometimes has multiple species within it. My understanding is that if that is the case, because there can only be one tmin tmax corresponding to a row, right? Because there's only one entry for a tmin and tmax in that row. So my understanding, and I think I confirmed it with one of the other notebooks that I previously run, is if that were the case, then the recording ID is duplicated, the species ID is not, and the tmin tmax are different. Do you follow what I'm saying? That's in fact one of the reasons that in FastAI we had to process the labels in order to create a multi-label category where you could have multiple labels corresponding to a single recording ID.
Yes, that's correct.
I
explored labels a bit, and most of the examples, most of the recording have single label, but some has multiple. And there are many examples which have like two labels of the same kind. So it would be just two time
difference. Like different times, but the same label.
Like 2 times when the same species is recognized.
But here is it.
Yeah, I saw that too. There was.
Has he not though changed it though? Because you remember, like when he did like all of the pre-processing of the spectrograms, he just put out one image per row of the data set, which is like only one species per row, isn't it? Although you can have multiple species.
No, but that's what I wanted to clarify, Steve, that if that is the case, even your original recording ID or your original data set had a separate recording ID for that species ID. So he doesn't lose that. He still gets that because he's doing it for every row in the data set, and every row has, a species.
Yeah. Yeah, so,
right. So he doesn't lose that, but
he has one image for each row of the data set, but it's possible, like within that 10-second window, that you have more than one species, but there's only sort of one main species that he's centered on. So
yes, but even the original recording doesn't have multiple species because it only has one tmin tmax corresponding to a window. It could, again, if we go back to how it was corrected, it could have had it, but it only flags a single label.
Yeah, but it's possible within the WAV file or whatever that you have multiple species within the same time window, isn't it?
No, but that will again show up as a separate recording ID and with a separate label in the data set.
It would be the same recording ID, wouldn't it? But it would just be different time windows.
Different time windows, then it will have to be a separate row, and we'll have that label corresponding. And he's processing every single row,
with
right?
A single label, right? So if there are overlapping this sounds, then this processing will lose that. So it will have only a single label per. He like turns it from multi-label classification to multi-class classification, essentially. So he has a single label per example.
Correct. And in fact, the data set, that's the thing I wanted to highlight. The data set has that. The data set is forced to have that because there's only one tmin tmax.
Yeah, but like theoretically, tmin and tmax for two rows could overlap on a single
Oh, yeah.
track.
But as long as you're processing each spectrogram separately for each row, that overlap doesn't really matter.
But does it not?
Because you will get another spectrogram. The fact that it's a picture which overlaps with some other picture, you don't really care.
But
Well,
is
but
it
you
not
want
like,
to
yeah, you could have one row, which contains just a single species within that time window, but then you could have like another row where that same species is overlapping with another one, and so its spectrogram will look completely different because of the fact there's two species within the one image, but you haven't labeled it as such. So like if the tmin and tmax
yes,
on different rows overlap.
Yeah, that is possible, but sorry, go ahead, finish, Steve.
Oh, well, that was it really. It's basically that, yeah, although you've sort of centered the spectrogram window on one species, it's possible that there's multiple species in that image.
Yeah, but that is an inherent problem with the data set. There's not, because the data set only identifies the prominent species corresponding to a tmin tmax.
Oh,
in the way that the data is stored itself, right? It gives you a single tmin tmax for a particular species.
But
now,
is it not say? Is
a
it not
recording
saying like,
ID could be duplicated?
Yeah, I thought it was like saying, well, here's like 60 seconds of sound, and for each row, it would say, okay, and species number 1 is within this tmin and tmax and this recording ID, then species number 2 is in this tmin tmax. But I thought it was possible for those two to overlap each other, and it's just they're on separate rows, but you could work out if they're in the same 10-second window from looking at their tmin and tmax values. And so you could label it as a multi-label for each thing as opposed to just a single.
But the way, yes, what I don't know is whether there are overlapping sounds within the same tmin tmax. I haven't done that analysis to figure out, but to see whether there are multiple species within the same tmin tmax. But the way the data is provided is that's split into separate recording ID, species ID, tmin tmax rows.
Yep.
So for a single row, there's only a single label corresponding to a combination of tmin tmax.
Yep.
So that's something, again, I kind of grasped as he went through this processing. Now, so then you start the training loop, you find out the max of the output, and these are just the values, but these are the answers and the targets, and wherever these match, those are correct. So you found out that the target matches what is the label. The answers match the targets, which are the labels, and therefore you find the correct. So you kind of the proportion that is right, and you do the validation, obviously, with the held out, 20%. You find out here you're training, here you're validating, and then you print this. And then here he's just saying, based on the epoch, you save the model that's the best based on your validation score. And then he deletes the model at the end in order to feed. After he has saved it, kind of delete it in order to save space. That's what you go through here. And that's kind of completes the training part of the exercise. Now here he just did it for one loop, and I'll quickly go through in a separate notebook once we're done with this, the modification, everything else being the same, just the modification to do it over multiple folds and then combine the results. Then, and this is the part where I have a little bit of an open question because I ran out of time in analyzing this portion completely to where I can fully get it. So that's an open question, much like the, to me at least, much like the positive weights. Here what he does, so now you have, you've trained the model to recognize, as Arto correctly summarized, he's converted a multi-label problem into a multi-class problem. So you have the classes, you have 23 classes, and you have to recognize the 23 classes in the data that you're provided. Remember that you did that over a 10-second sample with the center positioned, right? And then at 10 seconds between 488,000 samples. So here you want to do the same thing on your validation sample. So you can chunk the output, the test thing into 10-second chunks and realize PCs within the 10-second chunks. That's kind of what he's going to be doing in the testing, as we would probably guess. So that's what he does here. He splits the test data into segments. He counts the ceiling of segments because you don't want to leave any portion of the actual waveform unchecked. So you don't want to say if it is 2.3, then you want it to go to 3. And then here all he is doing is, as I said, if your segment is at the very end of the wave, then you do this weird stuff of taking the length of the wave and then subtracting and then going to the end. You can, if you draw some pictures to yourself of, hey, you have an odd, a fractional segment, then what would you do? But the easier route is, meaning the more simpler thing would be when you have an integer type of stuff or whatever, or in the more natural case, you would do this until you come to the fractional case, which is you just go from I times length to I plus 1 times length, because you just go to segment starting at 0 and then take the first segment, which is of length, and then you go to the next segment, each of the segments being, obviously of the length of the wave divided by the length, right? So you want to divide whatever the wavelength is by the 480,000 samples, which are in your length, and determine the number of segments and go from there. So that's all he's doing here. Converting it again, you do to the validation exactly what you did to the training, go through the same processes before, return the MEL array, load the model back, do the evaluation, and then generate the output. Right now, the part that I wanted to dive into and that I can't, if you poked at it in detail, I wouldn't be able to explain in detail to you what the specifics is, how this particular thing, I understand the last part, which is also very interesting. I'll explain that in a minute, but I don't fully grasp, and I need to kind of print all of this and figure that stuff out from Matter, which is taking the max prediction from all slices per bird species. So that's something I need to dive into. That seems to suggest that he is kind of saying, I'm going to, see what's the max result, and I, from each of the chunks, and I'm going to take that as the prediction of that chunk for that particular bird species. So that's, I think, what he's doing here. But how that works with the output, I'll need to kind of plot or print out a couple of data points in order to figure that out. But once that's done, then he just prints that submission out and creates that submission for the 1,993 test values that you have. The other fascinating thing here is in this competition, because it is label weighted, label ranked average precision, you don't really need to convert the output to probabilities. The reason why is as long as your values are in some rank order and the rank order doesn't change based on what you're computing, meaning as long as the values are consistent with the rank order, you don't need to get the values between 0 and 1. You can let them be whatever they are. If they are logits, they are logits. If they are numbers, you can let them be that, because all you care about is just the rank order of the species. Does that make sense? The last part of what I said?
Yep.
You don't need, because ultimately converting it to probabilities gives you the same thing again. It's just that the values are between 0 and 1. The rank order won't change if you take it through and convert it to probability, because your highest probability stuff will have whatever the corresponding highest number. That's why you're getting a highest probability. And as long as you only care about the rank order, you only care about the order of the numbers, whatever the metric be. It doesn't have to be between 0 and 1. Because of the way the metric is being judged for this competition. Questions on that? Okay, and then he just submits the results. And as you see, the results are better than what has been achieved before. This also, to me, Steve, kind of gives you an understanding of what you would potentially do with the data, what are the various options, and somewhere else, and I don't know whether, as I was just poking through some documentation and things like that, maybe the size of the window of 10 seconds is large. You can take 5 seconds, and then in which case you would again go and do the same thing on the validation side to ensure things. I mean, that's another option to vary. And then obviously applying, and we have discussed this before as well, applying augmentation to the spectrogram. And in fact, I think one of the notebooks I already shared had a couple of simple augmentations applied, like white noise or something else. So what augmentations are best for really extracting information from spectrograms? Also, he limits the frequency ranges, right? And is there more or less information, or is there smarter ways to do that? Is another what Arto brought up of, you just duplicate the channels. Are there better ways to get more information on the other channels as you go through the processing? These are all things that, and then is it better to convert when you generate the MEL spectrogram to an amplitude or to power? These are all various questions that, or various knobs you can tweak. One more thing he mentions, and I think that's somewhere else I saw as well, is he uses binary cross entropy, right, as with logits as the loss function. But that doesn't quite correspond to what we are trying to optimize in terms of the metrics. So that's something else we could look at, is are there better loss functions that we could use as well? These are all the various things I could think of to play with respect to this notebook and try to get your numbers higher than what they are right now.
But what would you say is
comments or thoughts, and I'll just spend. Sorry?
Why would you say that binary cross entropy wouldn't correspond to what we're trying to optimize? So the matrix we have is like this, I don't remember how it's called, but basically those are like we want correct labels to be of the highest rank. So to be highest rank for current example, and binary cross entropy would do just that, if I'm not wrong.
Yes, no, I thought so as well. It's a good question. I am reacting to what more to his comments in here. I agree with what you said about, I was wondering about it myself. So what else would you use? Because of what you just said, that even to me, you know, this seems like the appropriate metric. I was just making that comment based on what he said. And I'd be curious as to what other loss functions have been used by people.
I think, like, obviously, because of the fact that he's like split the thing into like 10-second windows, and he is effectively classifying one species per window, as opposed to like ranking all of the species that's in the whole 60-second window. So he sort of has to use binary cross entropy to get his loss function to train his model. But like, obviously the result that he gets out of that then doesn't match with what would be on the public leaderboard or the private leaderboard. And so, yeah, like, obviously a lot of people, they like their models, like the scores that are coming out, to sort of match with how they would do on the public leaderboard, so as they can see how their model is faring in the overall scheme of things. So like, maybe that's what he's talking about. It's like his loss functions that he's getting and the results that he's getting aren't sort of directly comparable to the public leaderboard. I don't know how you would get it to be, because of
yeah, I mean, he does convert, but on the other hand, I don't, yeah, I'll have to look more to see, you know, because the other notebooks we saw earlier, they just, again, did the overall window, but I'll have to go back and check. I thought they also used cross entropy, maybe not binary, but
yeah, for
I'll have to go back and check.
For whole window, you have multiple labels per example, and there you have to use binary cross entropy, because like regular cross entropy wouldn't work. Regular cross entropy wants to output a single class, and binary cross entropy just outputs a score per class, which are independent. So we could have high score for each class if each class is present on their exam, like on the input, in the input. And in that regard, it seems to be quite appropriate for the metric we have here. And one problem which is possible here, he doesn't have any negative examples. And what he does at evaluation, he basically does a max pooling over all the scores. And as the model never saw negative examples, and he doesn't have a separate class for like nothing is here. And but at evaluation, he has a lot of slices where model should
example slices predict, where he would see that.
Yeah, nothing is present there, and this is his problem, not their own loss function, but rather
actually he does
mismatch here.
Right, he does make a comment again. This is something that, you know, if you want to add, and this also goes to the question I asked very early on in the competition, because by the way, to your point, Artu, none of the other notebooks I've shared so far, which again is appropriate because we're just making progress towards understanding all the elements of the problem, right, and what all you can do. None of the notebooks that I know of that we have gone through, that I have played with so far, use negative examples yet. They may not chunk the output, but they still take the whole waveform input, whole waveform on the test, and still do the same thing though. They do not use the FP files. So
by the way,
that
one question about that. Did you see any high scores with whole file? Like,
with what?
Without slicing. Did you see any like scores reasonably high without slicing the data?
You know, in the spirit of how we have dealt with these things, I've deliberately not looked at high scores and kind of want to build up from the bottom and get it. So short answer is no, I don't know.
Yeah. So just from like for my intuition, so when we have this, when we look at the whole file, we have like a following, and we don't use this tmin and tmax, right? We have like a label for the 1 minute audio, which is really a label for some like fraction of seconds. I have looked at the distribution of length of the labeled slices, and the longest was just below 8 seconds. So probably that's why he's using 10. And yeah, most are within 5 seconds. And basically with such a small data set, it's kind of like very optimistic to expect the model to really pick up on the useful part of the whole 1 minute audio to find this relative like to the label, seconds relative to the label.
Without chunking, you're saying?
Yeah. So I think that it probably would at least be need some smart approach toward chunking, and it's just probably simpler to chunk and better like shift your some good stuff to the how you treat negative examples and how you do post processing.
Right. Yeah, that's very interesting that you did the analysis of samples. Of the.
Yeah. Also, I checked some wrong predictions from my model, and I expected it to have this like I took top losses from the validation set, with a wrong prediction with top losses, whereas the model is confidently predicting something else, and I expected it to be those false positives, but yeah, so I think 4 of 5 top losses were not in a false positive list at all, and one audio file which had some like false positive labels, but what my model predicted wasn't that wasn't in that list. So it seemed to be that yeah, at least the model I trained, but it wasn't really like good, but it didn't fall into this predicting false positives. So that's one observation.
Interesting. Actually, Arto, since you've done a lot of that analysis, what I'd like to do is maybe next time, here we're almost running out of time, but next time maybe you should kind of share the notebook and take us through that to begin with, and then we can see what else. That would definitely show us the analysis you did on your model and things like that.
Yeah, sure. But I didn't do like a lot of analysis. It was like really just top of the iceberg, I would say. Maybe I was just thinking that in this case, this GRET CAM or something like class activation maps would be useful to see if the model
I've seen
the correct
people do grad cam to see whether it's focusing on the correct portions of the spectrogram where the frequencies of the show up. That's an interesting thing that could be applied. Another thing I've seen them do is obviously what you talked about, which is some kind of confusion matrix and finding out, what your model says versus what the actual reality is. Which, by the way, there's one comment I wanted to make with respect to the loss, because all this focus on the negative examples triggered this thought. One thought could be that the focal loss could be used here potentially, because isn't the case that the focal loss actually also kind of addresses the same problem, that there are so many negative examples in, for example, object detection, that you then want to compensate for that situation. And so that might be something to look at as a potential enhancement or a difference in loss function to compensate for what you were mentioning, that it sees a lot of negative examples in the validation case, which it doesn't see at all in the training case, or at least not as much, and therefore will suffer from some issues.
Yeah, that's definitely makes sense. I was thinking also about that this task kind of like have some relation to object detection in this matter.
Right. So focal loss is something I was thinking about as we were discussing, that might be appropriate here because of exactly the problem you stated. Okay, we are running out of time. I don't want to go too much over. So what we do is just, if I'll again post a link to this, I'll just show you guys that here this an enhancement somebody else made to the notebook. Bottom line, you just train on, instead of a single fold, train on all the 5 folds. Obviously, as we discussed and as Steve highlighted, that is going to be a lot more compute. You can see, I just wanted to say, yeah, say fold 3. So there are 5 folds. So each fold, and then what's interesting to me is the way the fold predictions are combined. So you go through all of it, you do the same thing, and for each fold you use the model, and then in fact, what's fascinating is, you just kind of like this part, and I haven't, as I mentioned, gone through it in detail of how prediction is made on each chunk, and then the chunks are just combined, or the models are, here he just combines the outputs and averages them. Right? So straightforward averaging of the predictions from each model to get the final thing, which then is what is written out. And again, here, I don't believe there is a need to convert to probability, because ultimately you only care about the ordering and not about the actual values. So that's all this does, but it's not as simple as saying that's all, because the code has to be modified and then you have to ensemble, and how you do that is the interesting part, right? So that's, you have to ensemble 5 different models, and this is something which is very fascinating. So again, I'll post the links to these, and as I mentioned, 3 questions that I still have to dig into. If you have time, interest, please get into it and help us all learn more by providing some answers. And yes, if you can reach out to the weights and biases guy, we can even give him the time next week or whenever he's available. And we'll start with maybe your model and any basic analysis you've done next time, and maybe any further work that anybody is able to do between now and then. But hopefully this 2 notebooks and going through them in detail helped give some ideas of what next to do, Steve, after you had done the spectrogram, or even how to what to focus on with the spectrogram, or what to save, and that kind of stuff, because I felt these were instructive in going through the details and figuring out what is being done.
Yeah, that was good. Thanks. I think I know where to go from here. So that was good.
All right, cool. Thanks for interesting
Thank you.
discussion today.
Okay, great. Thanks a lot, everybody. See you all next week.
Cheers. See you next